When you picture a shipping container, you probably just see like a big corrugated steel box, right? Maybe it's sitting on a ship or a truck. Kind of mundane.
Yeah, seems simple enough on the surface.
But if you dig just a little deeper, you find out these aren't simple boxes at all. In fact, in a lot of really crucial situations, they're becoming incredibly sophisticated systems. Highly protected, secure.
Absolutely. We're talking serious engineering here. Stuff designed to protect against threats you might not even think about. Bullets, bombs, yeah, but also like extreme heat or cold, and even really clever thieves.
That's right. The humble container, in many cases, is basically being turned into a kind of mobile fortress. It's critical, often totally unseen, but vital for global logistics, military ops, humanitarian aid.
And definitely for handling hazardous materials safely. Stuff most people, frankly, would rather not think about needing to move around.
Exactly. And that transformation, that sort of hidden complexity, is what we're diving into today. We've got a stack of sources here. There's research on composite armor materials,
Uh-huh. Market reports on military transport containers.
studies looking specifically at how containers get tampered with some really surprising stuff there.
Oh, yeah. And research into these super specialized vessels for dealing with dangerous cargo, like unexploded bombs.
So our mission really for this deep dive is to take all this information and, unpack it. What makes these containers protected? What makes them secure?
What kind of diverse needs do they actually serve? Sometimes pretty extreme needs.
Right. And look at the materials, the technologies involved, based on what these sources tell us.
And understand the threats they face. We'll just use everything right here in front of us.
Okay, let's start right at the beginning. The structure, the shell itself. How are these things built to actually withstand impact penetration? The sources talk a lot about composite armor.
Mm.
Okay. What is composite armor based on this? How is it different from just, say, a thick slab of steel?
Okay, so at its core, composite armor and the source on protective materials defines it pretty clearly. It's basically a protective material made from multiple layers, different materials layered together.
Not just one solid block, then.
Exactly. Typically, you'll see things like steel layers combined with fiber-reinforced composites, among other things. The whole idea, the fundamental principle, is to combine these materials to get superior anti-penetration performance, better than you might get from just one single material, even if it was the same weight or thickness.
So it's the layers working together, the synergy.
Precisely. And the sources really emphasize that ceramic materials are often key players in these layered systems.
Ceramics, like pottery.
Huh. Well, not quite like your coffee mug. We're talking high-performance ceramics, things like silicon carbide, boron carbide, that's B4C sapphire, alumina. There's a big focus in the research you see on lightweight materials.
Why lightweight?
Because weight is almost always a critical factor, right?
Yeah.
Especially for vehicles or mobile structures. So ceramics, fiber composites, they even mention advanced stuff like graphene. These offer low density, but also excellent ballistic performance.
Yeah.
Getting that high protection without adding tons of weight is absolutely key.
Okay, that makes total sense. You need the protection, obviously, but you can't have a truck that's too heavy to move or a ship that sits too low in the water.
Exactly.
But how do these different layers, these different materials, actually work together to stop something like a bullet?
Mm-hmm.
It still feels a bit weird, maybe, that layers of different stuff would be stronger than one really thick piece of, I don't know, hardened steel.
Yeah, it's all about managing the energy of that incoming projectile. You need to distribute it, dissipate it, soak it up. The source on composite armor research gives some really good granular insight here. In layered structures for protection, especially against ballistics, they often put a ceramic layer near the front.
Towards the impact.
Right. Materials like boron carbide, B4C, are pretty common for that front-facing layer.
And what's the ceramic doing there specifically? Is it just a hard surface?
It's more than just hard. Its critical job is to interact with that projectile and, crucially, deflect its energy perpendicular to the direction it was coming from. Think of it less like a simple shield and more like a disruptor.
Okay.
Ceramics get picked because they have incredibly high stiffness and hardness. So when a projectile hits that ceramic layer with a lot of kinetic energy, it causes this localized, intense shattering zone inside the ceramic.
So the ceramic actually shatters when it gets hit. That sounds bad, fragile.
It sounds fragile, yeah, but that shattering process is actually key to how it protects. When the ceramic fragments and crushes, it absorbs a significant amount of the projectile's kinetic energy right there. Plus the fragments that get created from the ceramic and how they interact with the incoming projectile. That helps dissipate even more energy. Those sharp ceramic fragments can erode the projectile, deform it, maybe even blunt the tip as it's trying to push through.
So the projectile basically gets chewed up and slowed down right at the first hurdle.
Pretty much, yeah. It takes that initial, really violent hit, disrupts the projectile, breaks itself apart in a way that absorbs energy, and hopefully starts deforming the threat.
Okay, so the ceramic does its job, takes the initial shock, disrupts things. But the projectile, or what's left of it, it's still moving, right? What happens next?
Right. That's where the fiber-reinforced composite layers come in. They act as the crucial backing material. Their main job is kind of multifaceted. They need to absorb the remaining kinetic energy, which hopefully has been significantly reduced and messed up by the ceramic layer. And critically, they need to catch and contain the fragments. That means the debris from the shattered ceramic and any bits that might have broken off the projectile itself during that violent impact.
Like a high-tech catcher's mitt, then.
Yeah, exactly. But one engineered for, extreme impact. The source mentions quite a few high-performance fiber types used here. They talk about their great characteristics: high tensile strength, high modulus, meaning they resist stretching, and low density.
What kind of fibers are we talking about?
Examples given are E-glass, Kevlar, which lots of people know from body armor,
Right.
carbon fiber, and also UHMWPE, that's ultra-high molecular weight polyethylene fiber, sometimes known by brand names like Dyneema or Spectra. The research even mentions looking into natural fibers.
Natural fibers, too. Interesting.
Yeah. And these composite materials, they work through really complex failure mechanisms when they get hit. Things like the resin matrix cracking, the different layers actually delaminating or separating, the bond between the fibers and the resin failing, and eventually the fibers themselves breaking. All these different ways of failing soak up energy.
Wow. Sounds like a really intricate dance of materials, then. Each one designed for a specific part of stopping the threat. Ceramic breaks it up and slows it down. Composite catches and absorbs the rest. How do engineers figure out the best combination, the best order?
Yeah, that's where ballistic testing is just fundamental. It's highlighted all over these sources, especially the one on composite armor research. You have to actually fire different types of projectiles, bullets, fragments, maybe even simulated rocket impacts at various armor setups. That's essential to understand how they perform and develop systems that actually work.
Makes sense. You got to test it.
The research discussed here specifically focuses on these experimental tests, exploring different ideas like dual-layer ceramic tiles, and importantly for containers, combinations of steel and composite materials.
And that research had a really interesting finding about layering steel and fiber composites, didn't it? Something that maybe wasn't immediately obvious.
It did, yeah. And this is a really valuable nugget, especially for building protective structures like containers. The research on steel combined with fiber-reinforced composites, it came to a pretty clear conclusion. For a system using both, putting the steel plate in front of the composite layers gives you better anti-penetration performance.
Steel in front. Really? That does seem counterintuitive. My first thought would be, put the composite first to absorb some energy, then have the strong steel plate as a final stop. Why is steel first better, according to this study?
Well, the study looked closely at the failure modes, how the materials actually break down during impact. That explains it. When the steel plate is the front layer, it undergoes something called shear failure. The projectile basically tries to punch a plug through the steel.
Okay.
The composite backplate then has to deal with whatever energy is left, plus that deformed steel plug. And its failure modes in that situation involve the layers separating, that's interlayer delamination, and the fibers stretching and breaking, which is tensile failure.
Right.
The research found that this specific sequence of failure, starting with shear in the front steel, is just more effective at stopping the projectile compared to putting the composite first.
So the way the steel deforms kind of sets up the projectile in a way that the composite behind it can handle more effectively.
Exactly. It seems to prepare the threat, if you like, in a way that plays to the strengths of the composite's energy absorption mechanisms. And they didn't stop there. They went even deeper, looking at combinations of different fiber materials behind that steel plate.
Ah, yes, the steel, Kevlar, and UHMWPE combination.
Precisely that one. They specifically analyze a setup with steel as the front plate, then a Kevlar fiber composite layer, and then a UHMWPE fiber composite layer as the very back plate. Their conclusion was quite specific, a key insight here. Steel first, Kevlar second, UHMWPE third in that exact front-to-back order showed the optimal anti-penetration performance among the setups they tested.
Steel-Kevlar-UHMWPE. Okay, that order feels very deliberate. Why is that specific sequence the winner? Is it just adding layers?
No, it's about which layer does what best. According to the study, the really excellent tensile properties of UHMWPE, its ability to stretch and absorb energy before breaking, contribute more to the overall starping power when it's used as the backplate.
The last line of defense.
Right. Remember, those back layers are dealing with the residual energy and fragments after the initial impact and interaction with the steel. HMWPE, with its amazing ability to absorb energy under tension, seems best placed to do that final energy absorption and containment job when it's at the very back.
That level of sort of tailored material engineering for a specific sequence of events, that's really impressive. It's not just slapping layers together, it's understanding how each material behaves dynamically.
It really is. It goes way beyond just looking at static material properties. It's about complex system design based on how things interact at high speed. The source research also noted some other factors that influence performance in that steel Kevlar study.
Oh yeah, like what?
Well, they found the type of projectile matters. A ball-headed projectile, maybe surprisingly, actually penetrated better than a flat-headed one of the same weight and diameter hitting the same armor.
Huh.
And, as you'd expect, the angle of impact is critical. If it hits at an oblique angle, not straight on, the penetration ability drops off.
Yeah.
Especially for a flat-headed projectile, because the effective velocity component hitting the armor perpendicularly is lower.
Right, so the shape of what's hitting you and the angle it comes in at makes a big difference.
Absolutely. And another point from that research was about higher velocities. While the total energy the armor system absorbs does go up with the projectile's impact speed.
Makes sense. Faster means more energy.
Right, but the effect of the specific armor configuration, like the order of layers or the exact materials, becomes less significant at very high impact speeds. At really extreme hypervelocity impacts, those subtle advantages of one specific layup over another tend to diminish. The sheer energy just overwhelms the finer points of the design.
Okay, so these principles of composite armor design, they sound incredibly sophisticated, driven by really rigorous research like this, mostly aimed at protecting vehicles and people, right? But you mentioned containers earlier. Are these materials strictly for military vehicles, or do they get used in the containers we're talking about?
Oh, absolutely. The sources are clear that these composite armor systems have broad applications. Yes, ground vehicles, helicopters, ships, but also mobile containers. They're used to provide protection against direct fire, shrapnel from mortars and artillery, even landmines. So the advanced material science and layering principles we've just been discussing are directly foundational to building these protected container structures.
Got it. And there was that surprising glimpse into future applications too, wasn't there? Something beyond just static armor plates.
Yes. The source focused on personal protective equipment, PPE, gives us a peek ahead. It talks about potentially exciting advancements involving, like, instrumented lightweight textiles.
Instrumented textiles, what does that mean?
The idea is to integrate tougher polymers and actually embed ceramic composite armor directly into flexible clothing.
Oh, armor in your clothes.
Yeah. And the vision goes further, creating full protection systems within the clothing, maybe with integrated warning systems, sensing impacts or chemical threats perhaps, thermal management systems to keep the wearer cool or warm, communication systems built right in, even integrated first aid capabilities.
That's amazing.
All potentially powered by flexible batteries embedded in the fabric itself.
So the whole idea of protective materials is evolving.
Yeah.
From just passive barriers to like active smart systems that are part of a soldier's or worker's gear.
Precisely. It shifts the concept from just passive resistance to active integrated safety systems connected to the wearer, providing information, maybe even responding. While some of this future PPE stuff might still be more R&D than off the shelf,
Sure.
the source indicates companies are actively working on applying these material science and integration techs. It really shows the direction things are heading: lighter, smarter, more integrated protective materials.
That really highlights how cutting edge this field is.
Yeah.
Starting from basic material properties and pushing toward these incredibly complex future systems. Okay, so we've looked at the science behind building a strong, protected shell, resisting bullets and fragments. Now let's shift focus to how these ideas get applied in the real world: logistics, defense. The sources point to a pretty significant and growing market for secure transport solutions.
Yes, they do. And the reasons why this market is growing are quite clear from that military tank containers market report we have.
Okay.
Key factors: increasing military spending and modernization programs around the world. That's a big one.
Makes sense.
Rising geopolitical tensions definitely play a role too. That drives demand for robust, secure logistics. And just fundamentally, there's a growing need for really effective logistics and supply chain management within military operations. It's essential for readiness, for effectiveness. All these things are projected to fuel pretty significant market growth.
Yeah, it makes perfect sense. If countries are spending more on defense, facing instability, they absolutely need reliable, secure ways to move and store vital stuff: supplies, equipment, people.
Exactly. And this is where we see standard ISO shipping containers getting adapted, heavily modified, really, to provide high levels of protection. The idea of mobile ballistic ISO shelters comes from this need, and we actually have a concrete, detailed example from the sources, the Fortune Transprotect.
Okay, tell us about the Fortune Transprotect. What is this thing? How does it embody this protected transport idea?
Right, so the Fortune Transprotect is described as a shelter-based transport system, specifically engineered to offer optimal protection for people operating in or being moved through hazardous areas.
And it uses that standard container shape we all recognize.
Yes, crucially, it's built within the dimensions and structural standards of a 20-foot ISO container. And that's a very deliberate, very strategic design choice.
Why ISO standard?
Because it immediately plugs into the existing global logistics network. Being ISO compliant means it can be seamlessly handled and transported by standard trucks, trains, ships, even aircraft. That gives you incredible flexibility and efficiency for deployment anywhere in the world. Gets protected capability where it's needed, fast.
So it looks and moves like any other container on the outside, but inside? It's a whole different story. What kind of protection does it actually offer?
The source is specific. It provides protection according to STANAG 4569 Level 3.
STANAG 4569 Level 3. Okay, what does that mean in practical terms? What does it stop?
Right. STANAG is a NATO standardization agreement for vehicle protection. Level 3 means it's designed to protect against significant threats. We're talking explosives, sniper fire, shell fragments, even certain types of mines.
Wow, okay. That's serious protection.
And it goes beyond just bullets and blasts. It also offers NBC protection, nuclear, biological, chemical, which is vital in modern conflict zones. Plus, it's built tough to handle extreme environments: sand, dust, high heat, bitter cold. The source mentions an operational temperature range from -32 Celsius up to +55 Celsius.
So STANAG Level 3, NBC defense, extreme weather resistance. That's basically a mobile bunker inside a shipping container. And it can carry quite a few people.
It can. The configuration described accommodates up to 18 people seated for transport. It also includes storage space, 80 liters per person under the seats, apparently, which is essential if troops are carrying gear. And they've thought about comfort and survivability, especially for long transits or in harsh conditions. It's got air conditioning, good ventilation, specified as 40 cubic meters per hour per person of fresh air.
So it's essentially a highly protected troop carrier, just formatted like a standard container.
That's a good way to think about it, yeah. But with a really crucial added capability. One of its standout features, highlighted in the source, is its autonomous operation.
Autonomous. How so?
It has a built-in power generation system, probably a diesel generator.
Yeah.
This lets it run its life support system's AC, ventilation for up to 10 hours, completely independently of whatever truck or vehicle is carrying it.
Oh, that's smart.
Yeah. It adds a critical layer of flexibility. It can function as a safe haven during stops, maybe in staging areas, or in forward locations where there's no external power readily available.
That autonomous power is a big deal. Turns it from just a protected box into potentially a self-sufficient operational hub for a while. What are the overall advantages listed for this system?
The source mentions several key ones. Lower operating costs, partly maybe due to a better passenger-to-driver ratio compared to some dedicated armored vehicles. The flexible logistics we talked about, huge, plus being ISO standard. Excellent ergonomics and comfort, which matters for troop morale and effectiveness on long deployments.
Right.
And critically, it's designed for multi-purpose use.
Multi-purpose.
Yeah.
How else is it used besides just moving troops?
Well, the source gives examples like configuring it as a protected mobile command post, providing a secure, climate-controlled space for planning and control right in a hazardous area.
Okay.
It can also be used for transporting wounded personnel or moving sensitive equipment that needs protection. That standard 20-foot ISO platform allows for different internal setups, different payload modules, adapting the same basic protected shell for various jobs. They even mention a related product, the Fortune GBTC, specifically a protected casualty transport container for up to 8 wounded. So this modular protected ISO container concept gets applied across different needs.
Okay, so this protected container concept, leveraging those advanced materials and engineering principles we discussed, is clearly a vital part of modern military logistics, offering flexibility, protection, even autonomy. Let's zoom out a bit now. Look at the broader market for these types of solutions, specifically military tank containers, based on that market report.
Right, yeah. This market report gives us that bigger picture view of the industry focused on moving fluids and other bulk stuff for the military. It breaks the market down in a few ways, starting with the different types of tank containers.
What are the main types?
They categorize them as flexible tank containers, rigid tank containers, and collapsible tank containers.
Is one type kind of leading the pack right now?
Yes, according to the report, flexible tank containers had the dominant market share back in 2023 and are expected to stay that way, showing pretty strong growth.
Why flexible? What's the advantage there?
Their key strengths are versatility, especially in really rugged or hard-to-reach places where getting a big rigid container might be tough, and they're easy to transport and store when they're empty.
Ah, okay. Makes sense.
Rigid tank containers, you could sort of put the Fortune Transpec conceptually in this rigid protected container space, even though it's not strictly for fluids. That's another very large segment. Valued for being robust, durable, and offering higher physical protection for certain cargoes or, obviously, personnel. And collapsible tank containers are a smally but growing segment, likely driven by logistics efficiency. They take up way less space when empty, which cuts down return transport costs and storage needs significantly.
Okay. And connecting back to our earlier discussion on materials, how does the market report break these down by what they're made of?
The report points to the key materials being steel, aluminum, composite, and fabric. Steel is still dominant, which isn't really surprising. It's strong, durable, pretty cost-effective for heavy-duty stuff.
Sure.
Aluminum is mentioned as gaining traction, mostly because it's lighter and resists corrosion, which is good for portability and for carrying certain chemicals or being used in specific environments.
And composites.
Composites are increasingly important, which lines up perfectly with what we talked about earlier, right? They offer those superior strength-to-weight ratios, lighter but still incredibly strong structures.
Yeah.
And fabric, of course, is essential for the flexible tank containers. That's what allows them to be folded up, adaptable, easily deployed, or packed away.
So we see those advanced composite materials playing a direct role right there in the military logistics market structure. What about applications? What are these military tank containers actually used for in the field?
The report details several really critical uses, each highlighting a fundamental need for military ops. Fuel storage is massive. Keeping a reliable fuel supply going is just vital for vehicles, aircraft, generators, everything.
Critical.
Water storage is also crucial, especially in dry or remote areas. These containers make sure troops have potable water. Chemical transport covers safely moving various hazardous materials, industrial chemicals, specialized fluids, whatever's needed. And waste management is increasingly important too, using containers to collect and transport waste streams safely, supporting sustainability efforts and environmental rules within the military.
Every one of those is directly tied to keeping operations running.
Yeah.
And who are the main users? Who's actually deploying these containers?
The primary end users are the different military branches and also private contractors. The Army is a major user, relying heavily on them for moving bulk supplies, equipment, keeping forward bases running. The Navy uses them for fuel and supplies at sea and in ports. The Air Force needs them for rapid deployment, getting fuel or water quickly to remote airfields.
Right.
And private contractors play a big role now, too, providing outsourced logistics and supply chain support to military forces globally.
It really sounds like a market driven by these constant fundamental needs and amplified by what's happening globally. What about the competition, the overall market dynamics?
The report paints it as a competitive space, shaped by a few key things. Rising defense budgets are obviously a major driver. More money means more demand for advanced logistics. There's a growing focus on efficiency and security in military logistics. Technological advancements, both in materials like we've seen and potentially in tracking and monitoring, are pushing innovation. Companies are investing heavily in R&D, trying to make containers more durable, more mobile, more adaptable.
Standard business drivers.
Pretty much. Strategic partnerships targeting emerging markets. Those are common strategies. The report also mentions recent developments, like companies boosting production to meet rising demand, and collaborations focused on innovation in container design and management. It's a dynamic field, constantly shifting to meet the complex needs of modern military operations.
Okay, so we've covered the heavy-duty physical protection, the armor against bullets and blasts, and how that translates into these specialized transport containers for military logistics. But even the toughest container faces another threat, right? Often more subtle, more insidious tampering, unauthorized access.
Absolutely. And the source from Leghorn Group, the security seal specialist, gives a really detailed and honestly pretty eye-opening look at this problem. It makes the point that even with security measures in ports like the ISPS code mandating controls and monitoring, using containers for illicit stuff, terrorism is mentioned, but also just widespread theft of goods is still a huge issue.
How big an issue?
The source estimates the value of goods stolen from containers annually is in the hundreds of thousands of dollars, which is just staggering.
Hundreds of thousands.
Yeah.
Just from containers. Wow, that's a massive drain on trade and, yeah, a definite security risk.
Yeah.
What's traditionally been the first line of defense against this, and why isn't it always enough?
The traditional first line is the security seal. Simple purpose, right? Provide a visual sign that the container doors haven't been opened since it was put on, supposedly ensuring the goods inside are okay. The source does acknowledge that modern, more sophisticated seals exist, and it's a big if, they're used correctly by trustworthy people all along the chain.
Yeah.
They are a considerable help.
But that, if used correctly by trustworthy personnel, sounds like a major potential weak spot.
It really is. The source is blunt. Any seal, no matter how fancy, can potentially be removed or tampered with if someone has the right tools, the knowledge, and the opportunity. But the problem goes way beyond just physically breaking a seal. Thieves have developed some surprisingly clever ways to get inside without obviously damaging the main seal. Makes detection incredibly difficult.
Ways around the seal, how do they manage that?
Well, one basic method mentioned is just messing with the seal itself, tampering or removing it. The source note seals are designed to resist some attempts, referencing the ISO 19712 standard for high security seals. But a really concerning technique they highlight, especially for plastic seals, is cloning.
Cloning seals, you mentioned this. How can they clone them well enough to fool someone?
Yeah, the source points directly at 3D printing technology. Criminals have gotten really good at using 3D printers to perfectly replicate plastic seals. They can copy the numbering, any custom markings, logos, everything. So they swap the original seal for their perfect clone, open the container, take stuff out or put stuff in, replace it with the clone seal. And it looks untouched, at least on the seal itself. This cloning is much, much harder to do convincingly with high-security metal bolt seals compared to plastic ones. The fakes are often easier to spot.
Okay, so a key vulnerability is just how easily plastic seals can be copied with today's tech. What's the countermeasure for that specific threat?
The source strongly recommends using high-security metal bolt seals, specifically ones that are approved and certified according to that ISO 19712.2013 standard. They are much harder to clone effectively. They even give a simple, practical tip.
Yeah.
Checking a metal seal with a hammer. A genuine high-security metal seal should resist it. If it's a fake, made of weaker stuff, a good whack with a hammer might cause it to break apart, revealing its counterfeit.
A simple hammer test, potentially exposing a sophisticated 3D printing operation.
Yeah.
That's kind of amazing in its simplicity. But the tampering methods go even deeper than just messing with the main seal, right?
Yeah.
You said they can get around it.
Absolutely, and this is where the ingenuity is really quite disturbing. The source details methods that completely bypass the main security seal by attacking other parts of the container doors.
They can open the doors without touching the main seal. How?
One method they describe involves using a crowbar to pry open the welded plate on the right door of the container. You know how containers have those vertical locking bars?
Yeah.
Usually the main seal goes on the handle mechanism of the right door, which locks over the left. By prying that welded plate, they can get access to release the locking mechanism on the left door from the outside. Once the left door is unlatched, the right door can just be opened easily, without ever touching the main seal on its handle.
Whoa.
And the source emphasizes spotting that this has happened after the fact. It's not easy for people who aren't experts.
Prying a welded plate, and it's hard to spot later. That really highlights how crucial specific inspection knowledge is.
It does, and there's another method described. Drilling the handle rivet.
Drilling the rivet.
Yeah. The handle you grab to open the door, it's connected by a rivet to the internal locking pole inside the door structure. Criminals can drill out that rivet, that disconnects the external handle from the internal pull. Then they can manipulate the pull or whatever's left of the connection to open the door.
Okay.
After they're done, they just replace the drilled out rivet with a cheap new one they bought somewhere. To make it look less obvious, they might even rust it up a bit, little water and salt make it look old, like it was always there.
Wow. Drilling a rivet and then aging it to hide the evidence? That is incredibly clever. And again, sounds really hard to detect unless you're doing a super detailed check looking specifically for that kind of thing.
Exactly. These methods really show starkly why relying only on that main security seal on the main handle just isn't enough. It won't stop determined, knowledgeable criminals.
So if they can bypass the main seal by attacking other parts of the doors,
Sure.
how do you stop those specific methods?
This is where barrier seals become essential. The source explicitly states they are required to effectively counter these techniques, like prying the door plate or drilling the handle rivet.
Barrier seals, what are those?
Barrier seals like the fork seal or the new fork seal mentioned in the source, which are also ISO 17712 approved, are designed to lock the two central barriers of the container doors together. Those are the metal rods or structures where the left and right doors meet and overlap in the middle.
Ah, okay. Locking the doors together right in the center.
Exactly. By putting a strong barrier seal there, you physically stop the doors from being opened without cutting that specific seal. It effectively blocks those methods that target the side of the door or just the handle mechanism.
Okay, so it's not just one seal on the handle. It's layering security. A high security main seal plus a barrier seal locking the doors together. Is even that enough? Or do procedures matter just as much?
Oh, procedures are absolutely critical. Physical seals are crucial, yes, but rigorous control procedures throughout the whole process are essential for a truly secure supply chain. The source gives a really comprehensive list of recommended precautions. It emphasizes vigilance at every step. It's about creating multiple layers of checks and balances.
What kind of procedures are we talking about beyond just using the right seals?
It's quite detailed, very practical stuff. First, a meticulous check of the seal before the container even leaves the warehouse. Then, carefully choosing who transports it. Trusted road carriers are critical. The human element, their integrity, matters hugely.
Right.
Planning routes carefully, giving strict instructions to avoid unnecessary stops, or leaving the container sitting somewhere unsecured, that's vital. Requiring the container to be weighed at departure and arrival, then carefully comparing the weights. A big difference is a huge red flag for theft, even if the seals look okay.
The weighing is key.
Definitely. Then, at terminals ports, rail yards conducting a detailed examination of both the seal and the container structure itself, not just glancing at the seal number. And finally, checking the seal and container thoroughly again at the final destination before opening it.
That sounds like a lot of checks.
It is. And the source really hammers this home. A simple check of the seal number isn't enough. You need to check the type of seal used. Ideally, compare it against photos taken before departure to make sure the original high-security seal wasn't cleverly swapped for a fake, even a really good clone.
That level of detail, multiple checkpoints. Sounds like a lot of work, but absolutely necessary given how clever those tampering methods are. It really is about building that secure chain of custody.
Precisely. It relies on the physical barriers, yes, but also human vigilance and strict procedures. And technology can help with those procedures, too. The source brings up electronic seals, specifically mentions RFID seals, like Leghorn Group's Myrmidon, as a state-of-the-art option.
RFID seals, how do they help with security?
Well, they provide basic status information you can read electronically. Is the seal new? Is it closed? Has it been opened? This gives you a digital record of the seal's integrity. It can help avoid arguments or doubts compared to just looking at it. And it makes certain types of physical cloning much less effective because the electronic signature wouldn't match.
Okay, that sounds useful. Adding a layer of verifiable digital tracking. Does this mean tech, like electronic seals, can replace the need for all those human checks?
But, crucially, the source makes the point again. Even with advanced tech like RFID seals, human control and detailed physical inspection remain essential. Technology gives you great tools, data, alerts, but the trained human eye, the personnel doing those detailed checks, the rigorous procedures, they are still vital parts of an effective, layered security system.
Got it. Technology helps, but doesn't replace vigilance. And what happens if, despite all these layers, physical seals, barrier seals, procedures, techmax, you still suspect tampering? What are the steps then?
The source lays out a clear protocol. First, check the seal again, really meticulously, even if it looks okay. Then carefully examine the container handles, the locking bars, the deer edges. Look for any suspicious signs. Scratches, pry marks, signs of manipulation. Look for those specific signs related to the methods we talked about.
Okay.
If you find anything unusual, anything at all, it's critical to write it down immediately on the transport documents before opening the container. Creates a formal record right then and there.
Document everything.
Yes. Take pictures, container, seals, main and barrier, handles before you open the doors. Crucial evidence. If the seal was broken or looks compromised, carefully collect all the broken pieces. Get them checked by an expert. Seal experts can often tell how a seal was defeated, cut and reglued, swapped, etc.
Right.
And the source also notes experts might be needed for more than just checking the seal. They might be needed to help prove what should have been in the container versus what is or isn't there now. Especially if seal tampering isn't 100% proven, but theft is suspected based on weight difference or subtle container damage.
That really underlines the importance of documentation, photos, and potentially calling in specialists to figure out exactly what happened. So, tampering. It's this constant evolving threat. Needs not just strong physical barriers, but this complex mix of materials, layered physical security, like barrier seals, strict procedures, and tech.
It's a sophisticated, ongoing cat-and-mouse game, really, between those trying to protect cargo and those trying to get at it illicitly in global logistics.
Okay, we've looked at armor for physical protection from outside threats, and seals, procedures, tech for security against unauthorized access from the inside. Now let's shift gears completely to maybe the most extreme, most specialized end of the spectrum today, transporting incredibly hazardous materials, specifically unexploded ordnance UXO and explosive waste.
Yeah, this is definitely a highly specialized and, frankly, dangerous area. Detailed in that DTI source we have, which focuses specifically on evaluating transport containers for ordnance and explosive waste cleanup projects. Particularly relevant for places like FUDS, formerly used defense sites, old training ranges, places like that which might still have dangerous explosive stuff left behind.
What makes transporting things like UXO or bulk explosive waste so uniquely challenging compared to, say, moving hazardous chemicals or even flammable liquids?
The core critical problem, as the source highlights, is that you often just don't know the history or the actual physical and chemical condition of the stuff you recover.
You don't know what state it's in.
Exactly. Unlike brand new munitions with known properties, known stability, UXO found on old sites could be decades old. It might be degraded by the environment, damaged somehow, just unpredictable. Standard safety procedures for near pristine munitions might not apply at all because you just don't know how stable this particular item is or how it might react to being moved or bumped. That inherent uncertainty makes the potential hazards, specifically the risk of an accidental, unplanned detonation during handling or transport, much higher and really hard to quantify accurately.
So the fundamental challenge is safely moving something that might, just might, unpredictably explode. And you don't know why or when. The critical question then becomes, how do you make it safer for the people who have to be near this stuff during transport?
Exactly. The main goal of the research and the development of these specialized ordnance containers is finding or creating vessels reusable or maybe even single-use that can effectively mitigate the blast and fragment effects if there is an accidental detonation inside the container.
Contain the explosion.
Mitigate it, yeah. And secondarily, these containers also need to protect the munitions inside from being accidentally set off if the transport vehicle gets into, say, a traffic accident.
Okay, so they need to do two things. Partially or fully contain an internal explosion and prevent an external event from causing an explosion. That sounds like a really tough dual requirement. What kinds of containers did they look at for this job in the source?
The evaluation mainly focused on container types, typically used by bomb squads, EOD units, explosive ordnance disposal, usually for handling just one item or maybe a few items at a time, not bulk transport like those tank containers we talked about earlier.
Right.
They looked at a couple of main approaches and evaluated them pretty rigorously based on a set of criteria: blast and fragment mitigation capacity, how well do they contain it, overall safety level, transportability, how easy are they to move around a potentially messy site and on roads, cost, maintenance needs, ease of use for the EOD techs, and just are they available? Can you get them?
Okay, let's start with the one that sounds safest, just from the name. Total containment vessels. What's the idea behind those?
Total containment vessels, TCVs, they're usually built as really robust spheres or thick-walled cylinders, and they are designed with a very specific, very ambitious goal to totally contain both the blast pressure wave and all the fragments that result from an accidental detonation of the ordnance inside the vessel. Nothing gets out.
Totally contained. That seems like the absolute gold standard for safety, doesn't it?
It's intended to provide the highest possible level of blast safety and the highest level of fragment safety, precisely because all the hazardous effects are meant to be fully contained within that structure. The source gives some examples and specific test results they analyzed.
Like the NABCO container, was that one?
Yes, the NABCO container is mentioned as a standard, commercially available TCV used by bomb squads. It's a serious piece of gear. A 42-inch diameter sphere made of 1.5-inch thick steel plate weighs about 3,500 pounds.
Wow.
The analysis they looked at showed this specific vessel had a safety factor of about 1.3 against yielding permanently deforming under the pressure from a single 10-pound TNT equivalent blast. Though they do note that fragments hitting the inside wall could potentially affect how it responds dynamically.
Okay. And Battelle seems to have tested a lot of their own container designs, too.
They did. The source details findings from testing Battelle designs of various sizes. For instance, a 2-foot diameter sphere tested with 6.5 pounds of C4 plastic explosive inside actually showed the onset of plastic deformation in the steel shell, which illustrates an interesting point about the dynamic yield stress of steel. It's actually stronger under very rapid blast loading than under slow static pressure.
Huh. Interesting physics there.
Yeah. A larger 3-foot sphere tested with 6.5 pounds of special gel, a type of dynamite, only showed an elastic response. It deformed but bounced back to its original shape, no permanent damage. They also tested 4.5-foot spheres, finding that 3.2 pounds of pentolite explosive caused the start of permanent residual strain.
So they're really pushing the limits in these tests.
Absolutely. A big 5-foot spherical chamber was tested repeatedly with 35-pound C4 charges. The analysis indicated low cumulative plastic strain over multiple shots, suggesting it could handle repeated blasts of that size, and it was predicted to be acceptable for a single, much larger detonation equivalent to maybe 70 or 80 pounds of C4. They found that using the dynamic yield stress property of the steel in their analysis matched the measured results from these tests really well.
That testing really defines the engineering boundaries, what these things can actually take. What are the main trade-offs, then, for this very high level of total containment safety?
Well, the main trade-offs, as you might guess, for these super robust, thick-walled structures are significant cost and limitations on transportability.
Expensive and hard to move.
Pretty much. These vessels can be really expensive. Costs mentioned range from maybe $10,000 for smaller ones up to over $100,000 for larger capacities. And while they're usually mounted on trailers or trucks for road transport, moving the bigger, heavier ones around a potentially rough, uncleared cleanup site can be difficult and slow. Maintenance is usually cleaning and inspection. Availability varies. Some are standard commercial products, others might need custom fabrication. So you get the top level of safety, but it comes at a higher price and with less operational flexibility on the ground.
Highest safety, highest cost, lower mobility. Okay. That definitely presents a challenge if you need to use them frequently across a big area. What's the alternative approach they looked at?
The alternative discussed is vented containers. These are typically designed as vertical cylinders, often with an open top.
Vented. So they're designed not to fully contain the explosion. That sounds less safe already.
Correct. The principle is fundamentally different from total containment. They are designed to control and vent the blast pressure and fragments upwards, out through the open top.
Okay. Is there an advantage to that?
There are benefits, yes. It significantly reduces the blast over pressure compared to an explosion just happening out in the open. And it directs the dangerous fragments mostly upwards. So it causes less hazard immediately around the sides of the vessel than an uncontained blast would. They are effective at stopping hazards from high-velocity, low-flying fragments that could hit people or equipment nearby on the ground.
Okay, so they manage and redirect the force and debris upwards. But if the effects aren't fully contained, how safe are they really compared to the total containment ones?
The source is very, very clear on this distinction. Because the blasts and fragments are vented, the effects are not totally contained. Therefore, potential hazards are still present in the area immediately around the vessel. They provide a low level of blast and fragment safety compared to total containment vessels. While they're better than nothing, you absolutely cannot consider the area right next to a vented container to be safe if something detonates inside.
Got it. Better than open air, but nowhere near as safe as total containment. What examples or test findings did they have for these vented types?
Examples mentioned include containers from Hurd's custom machinery, described as double-walled steel vessels filled with sand between the walls, open top, designed for containing things like dynamite. Another is the criminalistics SID container, also double-walled steel, open top, rated for a 20-pound explosive capacity. The source talks about test results showing that the measured blast pressures were indeed lower than what you'd predict for just a simple vented box, probably because of things like the sand fill or maybe a cover helping to mitigate it. However, and this is a really critical finding, while they do reduce how far fragments get thrown compared to an open blast, like by 26% for the Hurd's container in tests, the maximum distance fragments can still travel from these vented containers is significant. Hundreds of feet were measured. That's vastly greater than the distances considered safe just from the blast pressure itself.
Wow. So they reduce the hazard compared to open air, but you still need a huge safety zone around them because fragments can still fly really far. What are the trade-offs for these vented containers then, compared to total containment?
They are significantly cheaper, typically in the $10,000 to $30,000 range compared to potentially over $100K for TCVs. They generally offer better transportability around a cleanup site, smaller, lighter, easier to move on a trailer or truck. Maintenance is similar, clean, and inspect. And they're usually commercially manufactured, readily available. The key, crucial trade-off, hammered home in the source, is that these advantages in cost and mobility come at the price of a significantly lower level of safety for people and assets nearby compared to the total containment approach.
Are there any other container setups mentioned beyond these two main types?
Briefly, yeah. The source touches on ideas like trailers carrying multiple smaller containment vessels. That increases your overall capacity while keeping high safety for each item, but the total cost adds up, and it's less transportable than a single vessel because it's bigger and heavier overall. They also mention really large cylindrical containers on trailers or trucks designed for very big capacity items. These could potentially offer high safety, especially if they have an internal shield, but they're described as extremely expensive and very hard to move around a site because they're just so massive.
So looking across that whole spectrum of ordnance containers,
Yeah.
it sounds like there's a really clear but also really difficult trade-off between maximum safety and practical usability or cost, depending on the specific job and the risks involved.
That is absolutely the core conclusion, yeah. A critical insight from this research.
Yeah.
Total containment gives you the highest possible safety, basically complete protection from the effects. But it's generally much more expensive and less mobile. Might not be practical if you need to move lots of items frequently across a large or difficult site.
Right.
Vented containers, on the other hand, are cheaper, much more mobile, easier to use operationally on site. But they only partially mitigate the blast and fragments, and they still pose significant risks to the immediate area around them. You need those large, strictly enforced exclusion zones. The choice between them really comes down to balancing maximum safety against operational feasibility and cost for that specific cleanup scenario.
It really underscores the complex engineering, the tough risk assessments, and the practical realities you have to deal with when handling stuff that dangerous.
It's definitely a field where the engineering margins are incredibly tight, and the consequences of getting it wrong are, well, catastrophic.
Okay. Wow. We've covered a lot of ground. From the fundamental material science building the protective shell, to the diverse ways these protected and secure containers are used in military and civilian logistics, facing down that persistent, clever threat of tampering, and finally, looking at the extreme engineering needed for transporting the most hazardous cargo imaginable. Let's try and pull all these threads together now. What does this deep dive really tell us about the world of protected and secure containers overall?
I think it shows us a field that's far from static. It's constantly being driven by evolving threats on one side and technological advancements on the other. Those principles of composite armor and advanced materials we started with, they aren't just academic. They are the literal building blocks for the physical protection in so many of these containers. From the ballistic-resistant military transport, like that Transprotect, maybe even enhancing the resilience of other types, like ordnance containers, against impact or fragments.
And tampering challenges we looked at. They aren't just about stopping people from stealing TVs out of shipping containers, are they?
Not at all. Those techniques, bypassing seals, accessing doors, and tricky ways, they're relevant across the board. A highly protected military container with sensitive comms gear inside. A secure logistics container with high-value commercial goods. Even an ordnance container being moved across a site. They all need protection not just from external blasts or bullets, but also from internal compromise or theft. It just highlights the absolute need for layered security. Not just the container's physical materials, but also strong procedures, controls, and increasingly technological assistance.
We saw standards mentioned, ISO, STANAG, popping up in different places. What role do those formal standards play here?
Standards are incredibly important. They act as benchmarks, but also enablers. ISO standards, like the one for security seals, are just the basic container dimensions they ensure interoperability. Stuff fits together, works on the global logistics system. That's why building a protected shelter inside an ISO container frame, like the TransProtect, makes so much sense logistically.
Hmm.
And military standards like STANAG 4569 for protection levels. They set specific, really high requirements for defense applications. These standards don't just ensure consistency or help different countries work together, they also directly drive innovation. They set tough targets that manufacturers have to meet or beat, pushing the limits of materials, science, and engineering.
And technology is clearly weaving itself more and more into all of these different areas.
Absolutely. We saw hints in the military tank container report mentioning smart containers with tracking and monitoring as a growing segment. The electronic RFID seals are a direct example of tech enhancing traditional physical security and helping detection. And that future vision for PPE with embedded warning and comms systems. That shows where material science and digital tech are really starting to merge, creating actively responsive protective systems.
How do you see the technological integration maybe applying more broadly to all kinds of secure containers going forward?
Oh, you can easily imagine a future where containers have integrated sensor suites built right in, monitoring internal environmental conditions vital for sensitive cargo, detecting structural integrity changes maybe after an impact, even sending real-time geolocated alerts if someone's trying to tamper with it.
Smart containers.
Exactly. Location tracking, remote monitoring, that's becoming more standard anyway, provides visibility all through the supply chain or during deployment in dangerous areas. These smart capabilities add significant layers of security, operational awareness, maybe even predictive maintenance possibilities to what looks like just a simple box.
So what do you see as the main forces pushing innovation in this field? What's going to drive the next generation of protective and secure containers?
I think it's a mix of powerful factors. Definitely escalating global security concerns, everything from geopolitical tensions driving military needs to that persistent, sophisticated problem of commercial theft.
Hmm.
Then there's the relentless pace of technological advancement, both in material science, giving us stronger, lighter options, and in digital tech, enabling that smart monitoring and connectivity,
Hmm.
and just the continuous global demand for more efficiency, more reliability, and increasingly sustainability in logistics.
Yeah.
All these pressures together create really fertile ground for innovation in making containers tougher, smarter, and more secure.
It really sounds like it's a field that just cannot afford to stand still. It has to constantly adapt, evolve to meet new threats, leverage new possibilities.
It absolutely is. The world of protective and secure containers is incredibly dynamic. These aren't just static boxes, they're critical, complex pieces of the global movement and safety infrastructure, always leveraging new materials, new technologies, new strategies to counter evolving threats. They really are, as you said earlier, kind of unseen fortresses on the move.
It's pretty incredible, isn't it? To think about all that engineering, technology, vigilance packed into that corrugated metal shell you see rolling down the highway.
Layers upon layers of protection and awareness. Much of it totally invisible from the outside.
So we've taken this deep dive, journeyed from like the atomic level engineering of composite armor through how those principles get used in military and global logistics, confronted the clever reality of container tampering and the defenses needed, and finally explored the extreme engineering for safely handling the most dangerous materials on Earth. These containers, so often overlooked, play this absolutely critical, complex role, enabling everything from global trade to military readiness to environmental cleanup, keeping things moving safely around the world.
Yeah, they're the indispensable silent workhorses of modern security and logistics, operating right at that intersection of engineering, threat assessment, and operational necessity.
So, as technology keeps weaving its way more deeply into these physical structures, giving us smart monitoring, precision tracking, potential real-time alerts, how do you think that fundamental balance is going to shift? Will we end up relying more and more on the digital security, the sensors, the constant remote vigilance, maybe reducing the need for some of the really heavy-duty physical protection, the armor, the seals?
Oh.
Or will the container itself become this fully smart entity, sensing threats, maybe reacting autonomously? While human oversight, those detailed procedures we talked about, remain the absolute most crucial layer of security.
That is the fascinating question for the future, isn't it? As the container gets better at sensing and communicating, does that fundamentally change the risk? Or does it just give humans better data to act on? Does it reduce the need for physical protection? Or does it just make that physical protection smarter, more responsive?
It's a balancing act, I think, that will keep evolving as both threats and technology advance, defining the next generation of these mobile fortresses.